Hi everyone. Today we're going to study the second derivative test. Suppose f prime of x equals 0 and f double prime, or the second derivative, is continuous over an interval containing the point c. If the second derivative is greater than 0, or we say positive, then the function f has a local minimum at the point c. If the second derivative is less than 0, or we say negative, then the function f has a local maximum at the point c. If the second derivative of x is equal to 0, then the test is inconclusive. Let us see this example. Use the second derivative to find the location of all local extrema for the function f of x equals x raised to 5 minus 5x cubed. For our solution, the step 1 is to find critical points when f prime of x equals 0. This is our function here, so the first derivative will be 5x raised to 4 minus 15x squared. Let us set the first derivative into 0, so the left-hand side will be 0 equals 5x raised to 4 minus 15x squared. Now let us solve for x. Let us factor out the greatest common factor to each of the terms. So we have 0 equals the 5x squared times the quantity x squared minus 3. Now let us equate each factor to 0. So we have the 5x squared equals 0, and this x squared minus 3 equals 0. Solving for x in the first equation, we have x equals 0. On the second equation, we can transpose this negative 3 to the right, and then let us take the square root of both sides, and the value of x is equal to plus or minus the square root of 3. We have now these critical points, and we say that the critical points are the values when x equals 0, square root of 3, and negative square root of 3. Step 2. Find the second derivative of the function and evaluate it using critical points of step 1. A while ago, we solved for the first derivative. Now the second derivative is equal to 20x cubed minus 30x. We can simplify this expression into 10x times the quantity 2x squared minus 3. Now let us evaluate each of the critical points into the second derivative. Let's begin with the f double prime of 0. This is now equal to 10 times 0 times the quantity 2 times 0 squared minus 3. The 0 here outside makes the whole equation into 0. So the f double prime of 0 is equal to 0. Next, let us evaluate the f double prime of the square root of 3. This is equal to, we can simplify the radical and the power 2. So the number 3 here comes out as positive 3 to be multiplied to 2. So we have 6 minus 3. The difference will be 3, and that 3 will be multiplied to 10. So the f double prime of square root of 3 is equal to 30 square root of 3. Next, let us evaluate the f double prime of this negative square root of 3. This is now equal to 10 times negative square root of 3 times the quantity 2 times the square of negative square root of 3, then minus 3. We can simplify the expression here by cancelling the radical and the power 2. But take note, the negative sign here becomes positive. So when we cancel it out, the number 3 here comes out as positive 3 to be multiplied to the number 2. So we have 6 minus 3. And the difference is 3, and that 3 is to be multiplied with a 10. And everything now is simplified into negative 30 square root of 3. For step 3, let us now use the second derivative test. We say that if the second derivative is greater than 0 or positive, then the function f has a local minimum at the point C. Second, if the second derivative is less than 0 or negative, then f has a local maximum at the point C. But if the second derivative of the function equals 0, then the test is inconclusive, meaning there is no conclusion. Let us see now this f double prime of 0, and this is equal to 0. In this case, we say that it is inconclusive when x is equal to 0. Next is the second derivative of square root of 3, and the answer is positive 30 square root of 3. Since this is positive, we say that there is local minimum when x is equal to square root of 3. For the third critical point, and we have here the f double prime of negative square root of 3, and we found out that the answer is negative 30 square root of 3. Since this is negative, we say that there is local maximum when x equals negative square root of 3. Using the graphing facility, this is the graph of our f of x is equal to x power 5 minus 5x power 3. Let us examine the graph on its critical points when x equals negative square root of 3, when x is equal to 0, and when x is equal to square root of 3. We say that there is local maximum when x is equal to negative square root of 3, and it's here. Also, there is local minimum when x is equal to square root of 3. This is the point. And then, there is no local extremum when x is equal to 0. This is the point. This is now our final answer. Example 2. Use the second derivative test to find the extreme values of the function y of x equals 4x cubed plus 21x squared plus 36x minus 20. Step 1. Let us find critical points. That is, we will take the derivative of the given function here. So, y prime of x equals derivative of 4x cubed is 12x squared. Derivative of 21x squared is 42x. Derivative of 36x is plus 36. Derivative of negative 20 is 0. Then we let y prime of x equal 0. For this equation, the left side becomes 0. And then let us simplify the right side. We can do factoring here. We can see that there is a common factor on the three terms of the right side, and that is positive 6. So this is 6 times the quantity 2x squared plus 7x plus 6. We simplify further the equation by dividing this equation by 6. If we do that, we can cancel the constant 6 here. And the left side, same 0 will come. So we have 0 equals 2x squared plus 7x plus 6. Then we factor out. The factors are 2x plus 3 times x plus 2 equals 0. We equate each factor to 0. So 2x plus 3 equals 0 and the other x plus 2 equals 0. We solve for x. For the first factor equation, this positive 3 we transpose to the right, it becomes negative, then we divide by 2. So x equals negative 3 over 2. The x plus 2 equals 0. The positive 2 we transpose to the right. So x equals negative 2. These are the two values of critical points. Then step 2. Let us find the second derivative and evaluate using critical points. The first derivative is here, so let's begin taking the second derivative. Y double prime of x equals derivative of 12x squared is 24x. Derivative of 42x is plus 42. Derivative of 36 is 0. Now, let us evaluate the second derivative using the first critical point, the negative 3 over 2. So we substitute this value to the x. So it becomes 24 times the negative 3 over 2, then plus 42. We can cancel the 24 and 2, and this 24 becomes 12, multiplied by negative 3. So we have negative 36 plus 42. So the answer is 6, and this is positive. And we say that by second derivative tests, the function y of x has local minimum at x equals negative 3 over 2. What about second derivative with respect to the second critical point, the negative 2? So the function becomes 24 times negative 2 plus 42. 24 times negative 2 is negative 48 plus 42, we have negative 6. So the value is negative. By second derivative test, the function y of x has local maximum at x equals negative 2. Then we will go to step 3. I need to erase this part. I am going to copy the values of critical points here. Step 3 is evaluate the function f of x by local minimum and maximum respectively. Let's begin with minimum value. In our step 2, we say that the function has local minimum at the point x equals negative 3 over 2. So we're going to use this value to get the minimum value here. So y of negative 3 over 2. This is our function. So this function becomes like this. We change all the x by the value negative 3 over 2. Then let us simplify. The cube of negative 3 over 2 is negative 27 over 8. The square of negative 3 over 2 is positive 9 over 4. This negative 3 halves times 36, we will get negative 54. Then we simplify further. This 4 times this fraction will give us negative 13.5. 21 times 9 over 4 is 47.25. Then we copy negative 54 minus 20. Simplifying further, the final answer here is negative 40.25. Let us copy this value in here. Let's proceed with maximum value. From step 2, we say that the function has local maximum at the point x equals negative 2. So we will use this negative 2 to find the maximum value. That is y of negative 2. Our function given here becomes like this. We change all x by the value negative 2. Then let us simplify. The cube of negative 2 is negative 8. Times 4 is negative 32. The square of negative 2 is positive 4 times 21 is plus 84. 36 times negative 2 is negative 72. Then we copy the negative 20. When we simplify, final answer is negative 40. We copy this value in here. These are the final answers. Example 3. Use the second derivative test to find the extreme values of the function y of x equals negative x cubed plus 3 over 2 x squared plus 18x. Step 1 is to find the critical points, meaning first step is to get derivative of the given function. Y prime of x equals negative 3x squared plus 2 times 3 over 2x plus 18. So, this is the derivative of the given function. Let us simplify further. We can cancel these two with the denominator. So finally, y prime of x equals negative 3x squared plus 3x plus 18. Then we let y prime of x equals 0, meaning the left side becomes 0 and we simplify. We can do factoring here by removing a common factor. The trinomial has a common factor and that is negative 3. And it becomes like this. Negative 3 times the quantity x squared minus x minus 6. We can remove that constant negative 3 by dividing this equation by that same value. When we do that, we can cancel this negative 3 and the left side will just be 0. So x squared minus x minus 6 equals 0. We can factor this out. Factors are x minus 3 times x plus 2 equals 0. We equate each factor now to 0. So we have x minus 3 equals 0 and x plus 2 equals 0. Then we solve for x. In the first factor equation, negative 3 is transposed to the right. So x equals positive 3. On the second factor equation, this plus 2 we transpose to the right. So we have x equals negative 2. These are the critical points. Then we go to step 2. Let's find the second derivative and evaluate using critical points. Our first derivative function is here. Therefore, the second derivative equals derivative of negative 3x squared is negative 6x. Derivative of 3x is plus 3. Derivative of 18 is 0, so we don't write here. Let us now evaluate the second derivative using the first critical point. So we have y double prime of 3. This is our function. So it becomes negative 6 times 3, then plus 3. The product, negative 6 and 3, will be negative 18, then plus 3. So we have negative 15. So we have a negative value here. By second derivative test, the function y of x has local maximum at x equals 3. Then the second critical point, So we have y double prime of negative 2. So this function becomes negative 6 times negative 2, then plus 3. The product, negative 6 and negative 2, is positive 12, then plus 3. So we have positive 15. We have a positive value here. By second derivative test, the function y of x has local minimum at x equals negative 2. Now we go to step 3. I need the space here. First, I'm going to copy the critical points value, and it's here now. Then step 3, we evaluate the function f of x by local minimum and maximum respectively. Let's begin with maximum value. In our step 2, we said that there is a local maximum at the value x equals 3. So we evaluate our function with that value 3. So we have here y of 3. This is our function. So it becomes like this. We change all x by 3. Then we simplify. 3 cubed, and there is a negative sign outside, is negative 27. Plus 3 squared is 9, times 3 is 27, divided by 2 is plus 13.5. Plus 18 times 3 is 54. Finally, the answer here is 40.5. This is our maximum value. We copy it somewhere here. Then we go to the minimum value. In our step 2, we said that the function has local minimum at x equals negative 2. So this value of negative 2 we're going to use, and that will be y of negative 2. We evaluate this given function, and it becomes like this. We change all x by negative 2. Then we simplify. The cube of negative 2, we write here negative 8. Still the negative sign here is copied below. Then plus. The square of negative 2 is positive 4. Then the product 18 and negative 2 is negative 36. We simplify further. Negative and negative becomes positive 8. 3 times 4 divided by 2 is 6. And we copy the negative 36. And when we simplify, the final answer is negative 22. This is our minimum value.